Hi, my name is Bob Greenyer and I'm a volunteer with the Martin Fleischmann Memorial Project. So welcome this extra presentation on Friday the 3rd of October 2025, where we will be discussing Anatoly Klimov et al.'s novel plasma-focused detonator with carbon clusters and hydrogen ion fuel. Why am I doing this bonus presentation this week? Well, it's because I couldn't stop myself, really. Essentially, this is a combination of 3 different technologies, and they're all rather special. And we are going to just go over a couple of aspects of them. And what he has put together here is unique. It's all born out of 3 different Russian inventions. One is effectively the capillary discharge. The second is the Aramenco generator, and the third is the plasma focus type device, which is what it's called these days. There are other people that claim to, have a hold on that technology, but it really came out of Russia. So we're going to look at some points with respect to that. So, this is the rough schematic. I haven't gone into too much depth with it. However, what I have done is I have asked Anatoly Klimov if he would consider doing his presentation on the Martin Fleischmann Memorial Project's YouTube site, because I think this is a very significant development. And the AI and human-assisted translation doesn't always get it right, and I do think this needs to be right. Now, just like my own presentation and that of Vladimir Zhigulov, he found himself only offered a poster presentation at ICCF 26 in Morioka in Japan, and unlike myself and Vlad Zhigulov, who were in person, the poster presentation, when it's offered as an online presentation, I know from ICCF 24 in the Computer History Museum in Silicon Valley, I had 3 people read them and weep. 3 people attend my live poster session in ICCF 24. So it's basically a non-starter, doesn't get any hearing, but he has since sent the paperwork to be peer-reviewed. Now, I don't know whether he's referring to the journal for ICMNS or whether he's referring to another journal, but since sending the paperwork off, there has been a lot of questions. But he seriously argued that he would like to have presented this in person, and I genuinely think this deserves to have been presented in person. And it is a great shame that it wasn't, but here we are now. So what do we have? This little diagram pointing to 2 here. This is actually taken from his paper, and we're going to have a look at a bunch of papers that are relating to aspects of this invention. But the first point here is the Aramenco generator, which is a single wire generator. And this is the device, you may have seen video in the early 2000s of it, and it also being talked about by one Thomas Bearden in 1992 sort of period. This is a pseudo superconducting types affair occurs, and we'll look at the original patent and some attempts to replicate it by Jean-Paul Naudin, or Jean-Louis Naudin, I think, or whatever his name is. Sorry, Mr. Naudin. And it allows for a large amount of power, seemingly, to be transported along very thin wires without many losses. And it works actually at several voltages, so you don't have to run this at ultra-high voltages to reduce losses. You can actually run it at lower voltages. So we're going to have a look at that first. So if you give me a second, I'll pull up a few bits and pieces. I did have Adobe Acrobat loaded earlier when I was at home, but it's not here now. So we'll see if it picks up on the files I had loaded earlier. So some of the papers that I'd like to have got here are difficult to get, and really I wanted to get this out to you very quick and for people to start diving into what this is presenting. Essentially, there were quite a few problems identified by various researchers over the years, and one of them which I highlighted in my question of some of the people at MIT at this ICCF 26 is that if you were using expensive metals, expensively prepared in very difficult ways, then it's not going to be a practical technology for most people. It'll be useful for the military, possibly, but not for the general you and me. And the trick with some of these technologies is to use nanoclusters, and what do I mean by that? I mean very, very small particles. And the Cooley and Bennett patent that I found in the Matsumoto archive in Japan was using buckyballs, which effectively are nano clusters of carbon atoms in the form of almost like a football, and there's various sizes of them. The Buckminster fullerene is carbon 60, and that is what they were suggesting using with hydrogen ions in a situation where they had an electrical discharge and that's the kind of detonation process. So actually that's not too dissimilar, and I actually really like that patent because they show that the transmutation occurs in the core of a magnetohydrodynamic structure, which is equivalent to ball lightning. Anyway, if you just bear with me, I'm going to pull up a bunch of stuff here. So we'll run through Anatoly Klimoff's presentation. Why not? So here's Anatoly himself, and this is the blob of plasma coming out of his overall machine. And his objective was basically to use very cheap material rather than this expensive material in the form of lead, nickel and copper in extremely difficult to produce vapor deposition, such that Clean Planet have, and palladium systems. These are all very expensive to produce or very practically difficult for the man on the street. But what he's looking at is carbon nanoclusters and hydrogen ions. And so essentially he's creating a heterogeneous plasma, and he's using a method to explode that. And he's saying that it is his belief that they are observing extra thermal energy, and the COP is in the range of about 2 to 4. And basically, how could he saturate the hydrocarbon plasma and cause detonation? Now, I think the argument is that even in the hydrocarbon plasma, in such circumstances as he discusses, is already a COP of 2 to 4. Well, he goes into a whole bunch of papers here that he has published, and you can go and find the details there. In fact, I've got a couple of them to look at in a minute. But he says rather than use the method of calorimetry by looking for heat, it's very difficult and is open to all kinds of challenges, as we well know in the project. So he decided that, well, why not go to an explosive test? It's very simple to calculate, and well understood. And he argues that essentially the power of chemical reactions was originally determined by explosive shock waves. So you have the input you put in and the thing that comes out, and so you can work out the amount of energy that has been released. I do have one proviso with this, and that is if you get a situation where you get something like a PAP effect, where you build up clusters, I would call them energy clusters, energy solitons, and PAP used two methods. He used a radioactive source, which we know produces energy solitons from the work of Shishkin and the work of Ken Shoulders and all the team that work with Shishkin. And then you blow up those energy solitons, and they, in those authors' minds, produce up to 2 to the 10 power 11 electrons, which are then coulombically repelling each other, producing a shock wave. But the shock wave isn't necessarily a thermal release, although if it does work, that is, move a piston and has charge which can then be geared or rather coaxed into a magnetohydrodynamic electrical generation based system, as was the case in that of the PAP engine, then what does it matter if it's chemical energy or nuclear energy? It's recoverable mechanical and electrical motive force that can be got out of it. So there we go. So these are very old papers he's referring to here, and in fact one of the papers I have downloaded refers to these. So this is better described in his online paper at ResearchGate, and so we'll look at that. But the actual images in this presentation are of higher quality, because the paper on ResearchGate, the publicly available paper, is all in black and white, and so are the schematics and images, and they're a little harder to read. But essentially, he has a little capillary in here. He's using the Aramenco generator to produce a spark in here, which causes an explosive force to go through the capillary, and that abrasively removes a certain amount of the material of the capillary, which produces carbon nanoclusters and hydrogen. And then that goes down here, and that becomes effectively the anode of this magnetoplasma compressor. Of course, we know it's nice if it's got 6 electrodes around the outside. You can imagine an anode coming down here. You've got a right-hand rule. You've got a vortex going around that. These cathodes will effectively fire their plasma streamers into the vortex, and you can already imagine a fractal magnetohydrodynamic structure forming in the middle here. Now, it is not ideal from my point of view in that it's not a resonant phenomena, but can we get useful work out of this pulsed system? I think we can. And so it solves one of the biggest problems that we will look at, which has been causing very great difficulty for Eric Lerner in LPP fusion, and that is the erosion of the electrodes, and specifically the erosion of the anode. Because what Klimoff has done here is created a virtual anode out of the plasma stream, which is the fuel. And so this thing can actually work in free air. It is almost like a propulsion device that can work in free air. So it's a pulsed propulsion device, which is very, very interesting. So here you can see the setup. He has a large capacitor here. The Aramenco generator is connected to the back here. This is the cathode. And so, and there's some grounding going on with the anode, something like that. And so, essentially, and he's got a high voltage probe here. This is a normal microphone, as far as I can see, something like a Shaw SM58. He's using that as a shockwave detector. And then he's got another one here, which I think has got a piezo sensor in there. So he's seeing a shockwave here and a shockwave here, and there's a time difference, and he can calculate things. He calls them pressure transducers. And this three is the high voltage probe, and this is the capacitor storage. Okay. So the main physical mechanisms used in the design of this installation is a erosion plasma generator here, and I shared Anatoly Klimov's presentation on his work on plasmatrons, which produced, it would appear, coherent energy structures themselves. So you can imagine that coming out of this is coherent energy structures, which are already self-squeezing, and then the vortex coming in from all of these cathodes accentuates that process, and it's not constricted by the ordinary form of the magnetoplasma compressor, which we will look at. Yes, Ken, it is a big capacitor. So yeah, what you want in self-organization is not to restrict it. This is the problem with ITER. You are trying to tell the fusion, I want you to stay in this torus because this is what we can engineer. And that is the problem, in my view, with the ordinary plasma-focused devices up till now. With what Anatoly Klimov has done here is he's not only sending out potentially already self-organized clusters, which are already highly energetic and condensed in their energy, he's then putting that into a magnetoplasma compressor, a plasma-focused device, but it doesn't have an electrode on which to get in the way. The actual, it's almost like doing Winston Bostick ejection of plasma. And he describes how it works. If you can imagine your jet of plasma is coming across here, or towards you rather, the ions go out to the cathode and plasma streamers feed in back into the anode. But in this case, the anode is a virtual anode. So it produces vortices that are coming in like this, but they're also going like that because they're going around the anode as it's coming out. So this forces and encourages natural self-organization. I think it's absolute genius. It's absolute genius to combine these technologies. And there's no better person to have done it than Anatoly Klimov, because he's been working on these kind of technologies with some of the inventors or people that were close to the inventors since the 1970s. You go and have a look at his ResearchGate. He seriously has not been, on the periphery here. He's been right inside it. So he's the right person to have brought this about. And to just talk through some of the technologies here, the Aramenco generator, effectively, that was developed in 1978. And that itself was claimed to have a COP of 2 to 4. And it has been used in the past by people like Bitchkoff to investigate long-lived plasmoids and to try and simulate ball lightning. Okay, and this is being combined with the capillary erosion discharge, which was invented by yet another Russian group, and that was let me just see who that was. That was NN Augustsova and IV Podmoshensky and VM Shelemina. And they did a 1963 paper on the characteristics of plasma jets from powerful capillary discharges. This work laid the foundation for understanding the erosive aspects of such discharges, with later studies on it building on it, including a 1995 paper explicitly using the term capillary erosion discharge. So that's two Russian technologies. The first one was developed by the Russian physicist Stanislav Avrimenko, along with Konstantin Avrimenko in 1993, and it was developed for transmitting electrical energy over a single wire with minimal losses. Apparently it says it operates at high frequency of alternating currently, typically in the kilohertz range, and relies on reactive capacitance currents, displacement currents, and diode-based rectifier circuits. The basic setup involves a high-voltage AC generator connected to a single thin wire, e.g. tungsten or copper, with a receiving end featuring two fast-switching diodes arranged in a specific configuration, often called the Aramenco plug. Now, we mentioned that before as a detector for torsion fields. That charges a capacitor or directly powers a load like a light bulb or fan. Demonstrations have shown it powering devices through wires as thin as 10 microns over distances like 15 meters with no significant heating or resistance losses, resembling quasi-superconductive behavior. This is achieved in resonance mode, and so essentially, and it was patented. And so I've argued that this is a cluster that's traveling down the wire. The wire is being used as a guide, and something similar was drawn in 2012, I think it was, by one Maury B. King in one of his presentations about this kind of technology. And I referred to it in my Cosmic Summit 1 2024 presentation. And in also my practical applications to the fractal toroidal moment at ICCF 25. And it has been used in ball lightning research. So I'm going to try and pull up a whole bunch of stuff here so that we can look at this in terms of papers and patents, which I did prepare earlier, but it's all of a bit of a mess. Okay. Right. So there's one paper here. This is single wire electrical power system for renewable based electric grid. So Dmitry S. Strebkov, Stanislav V. Avrimenko, there's the man. The All-Russian Research Institute for Electrification of Agriculture. And he's saying here, low cost and low losses single wire electrical power systems, that they call it SWEPs, for a renewable based electric grid was developed. The new technology of electric power transmission uses idle operation regime of the transmission line and reactive capacitive current for transmission of active electric power. 3 different SWEPs were constructed, 230 volts, 10,000 volts and 100,000 volts. Each is of 1 kilowatt capacity. Resonant mode of the oscillation from frequency to 3 to 30 kilohertz was used to provide the most efficient power transmission. Frequency converter and modified Tesla transformer are applied at the generator site to generate high frequency reactive capacitive current. Reversal Tesla transformer and standard rectifier and inverter were used at the user's end to convert the reactive high frequency electrical power to standard 50 to 60 Hz electricity. It was experimentally proved that SWEPS has quasi-superconductivity property for reactive capacitive current flowing along the line, even at high operation temperature of the electrical conductor. So SWEPS has no resistance losses for following tested conductor materials of the line: copper, aluminium, steel, tungsten, carbon, water, and damp soil. They can transmit large amounts of power with no resistant losses over damp soil. The principle of SWEPS operation is based on the fact that in no load operation mode, the active current and magnetic field of single wire line is equal to 0, while the electric field of the conductor has maximum value, and this electric field is excited by reactive current, which is charging the capacitance of a single wire line and the electric load. The result of theoretical calculation and experimental study shows that SWEPs can be applied both for the energy transmission from renewable powerful generation site to a large energy system and for transmission lines for connecting different parts of a renewable energy system. Okay, so I will include these links later. It does all the maths and so forth. The patent is more specific, but here we can see some embodiments. So in A is for low voltage, 10 to 1000 volts. So it even works at 10 volts with quasi-superconductivity. It's absolutely fantastic. And then high voltage single wire line 1 to 1000 kilovolts is B. So there's slightly different configurations. But you can see here they've got these diodes and these capacitors and or set up with a load there. So 5 is the thyristor electronic key, and this is the 4 is the diode capacitor block here. So this is how it's set up, and I think it's really a rather interesting device. And there we go. Okay, I guess that's the resonance. You set up the resonance. Okay, let me see if I can find the patent for this. Okay. So here is the patent. It is WO93/23907, 25th of November 1993. Okay, and it's in all of these different places, but obviously it's expired. It was prioritized 8th of May 1992. So you can see this is right around the end of the Cold War, and you can see that Tom Bearden would be, he said he sent people to witness technologies in Moscow. One of them was a cold metal forming technology, which was then sent to London, and he verified it in London, and then it was reclassified and shut up. And the second one was transmitting large amounts of power over very thin wires, like an 8 micron wire is the quoted amount, or 10 micron, without any power loss. And this, I would believe, is that system. Okay, so here is a configuration here. This invention is in the area of electrical technology of a means for the continuous transformation of electrical energy with its subsequent transmission from the initial source to the consuming device via a single wire transmission line. The purpose of the invention is the creation of a highly efficient means for the transformation and transmission of electrical energy, employing both fixed and mobile devices, which transform the electrical energy of initial sources and transmit it to consuming devices in a manner involving significantly reduced losses of Julian heat resulting from the ohmic resistance of the transmission lines, and also the reduction of the metal content of such line. The invention may be used in conjunction with various power generating and technological processes based on the use of super high voltage electrical and electromagnetic fields, so on, blah blah blah. Anyway, that's your patent. And it has, I think, some similar patent drawings down here. Less detail on them than we saw in the previous drawings in the discussion paper. So he is using this Aramenco generator to send a lot of power from a Tesla system, I expect, because that's what Anatoly uses, into that area to create a discharge where he then, that discharge causes a shock wave that travels through that capillary tube, doing some erosion of that capillary tube and producing nanoparticles of particles of carbon and hydrogen in play. Okay, so that's that thing. Now, I think Jean, is it Louis Naudin, did some replications of this. And I will see if I can find that here. Okay. Okay, and we need to go. All right, let's see if this is going to work. Okay. So this is Nodan's site, and he's doing various experiments using this single wire here. You can see the transmission. It looks like he's got some component from a car there. And doing the transmission, light bulb at the end there. And then he also shows Aramenco himself, and with a spark gap at the end of a line here. So there is the single wire, and then there's a bunch of diodes, and then there's spark gaps at the end here around this capacitor. So showing the transmission of power. This is the same setup as experiment 2, but the single wire transmission line is now 15 meters long with a 0.2 millimeter wire. The power of the generator is a bit more increased, and Aramenco uses a bigger capacitor. When the switch is turned on, a 70 millimeter spark burst between the gap. So he's got a 200 micron wire over 15 meters, and he's producing a 70 millimeter spark. Of course, if you're sending EVOs, then not so hard to see why you would get a spark at the end. Here he goes. This is the same setup than the experiment 3, but the capacitor and the spark gap has been replaced by a light bulb. When the generator is turned on, the light bulb comes on, and then when Aramenco cuts a single wire, the light goes out. When he reconnects the single wire with a simple knot, the light comes on again. So actually, it's a big spark we want in the system to produce our erosion plasma through this capillary. So yeah, an Aramenco single wire is going in here, possibly to ground, to produce a spark, and then that produces this plasma, which effectively is the second electrode, and I guess that is also somehow touching ground. Okay, like I say, I need some clarification from Anatoly to get the absolute specifics right, and I hope he will come on the MFMP and talk about it. So the second invention, which is also Russian, is the Magnetoplasma compressor. But you might know it more from the work of LLP Fusion. Here, Eric Lerner's outfit. And here we have Eric Lerner talking about it. Maybe we can make it full screen here. And without getting a copyright strike, down your cathodes, you have your vortices or string plasmas forming, and then they come around the end here. That's the argument, and they go in, and hopefully they produce a pinch of pinches in here, and he argues that that twists up using kink instabilities, and then they kink up and kink up, and I argue it happens slightly differently, and in here they are able to do some fusion going on. Okay, now the interesting thing is that the Magnetoplasma compressor, the MPC, it is a specialized plasma device, and it was, as I said, originally developed in Russia for plasma fusion research. Okay, it was right from the outset developed for plasma fusion research, and the person credited with inventing it is Anatoly I. Morozov, and I can't find any source of his original paper available for download, although you can buy it in a book, one of 2 books, and there are some online publishing agencies where you might be able to get it as well. So if anyone's got that paper by Anatoly Morozov, then it would be great to hear that. And he conducted foundational, theoretical and experimental work on the process of this MPC and its principles in the mid-1970s. His early publications, such as a 1975 paper on the physical processes in the magnetoplasma compressor, are widely cited as seminal in the field's development. It uses magnetic fields to compress and accelerate plasma, generating high-velocity plasma jets or streams, and has been adapted for various applications, including supersonic flow control, aerodynamic studies, and even propulsion systems. Magnetoplasma compressors typically operate by creating a discharge in a gas, such as air or inert gases, and under specific pressure conditions, where electromagnetic forces pinch and confine the plasma, leading to self-organized structures and high energy outputs. In experimental setups, they can produce quasi-stationary or pulsed plasma flows for investigating phenomena like radiophysical effects, plasma dynamics, and interactions with supersonic flows. For instance, in air-breathing propulsion contexts, it enables ignition of dense plasma focus discharges at atmospheric pressure using nanosecond excitations, with energy inputs ranging from tens to hundreds of joules per pulse. Okay, so that is the basics of the invention by Anatoly I. Morozov. That is the magnetoplasma compressor. And in the presentation of Anatoly Klimov, he is very specifically saying that the process is magnetic compression, effectively. And that is very interesting to me. That is very, very interesting to me. Because I believe that is what this process relies on. So he's basically modernized the plasma focus by using a heterogeneous plasma cathode. Now, I think he might say this is actually an anode. I think it's an anode because he says in his presentation that all of these bits around here, these copper rods, those which the original inventor called hedgehog, those are effectively the cathode. So they can't both be cathodes. But anyway, I think he means that it's an anode. I need to check that with him. By the Erosion plasma generator in a new magnetic plasma compressor for the first time. And this really is original work. Step 2, creation of energy-saturated heterogeneous hydrocarbon plasma using erosive plasma generator with capillary discharge. And then his aim is to realize the what I call coherent energy transformation regime in the hydrocarbon plasma. And that is what is going on in the Bennett and Cooley patent, but on a resonance state. This is in a detonation state. So this is the hitting it with a large hammer. Using a trigger mechanism created by a magnetic plasma compressor, plasma focus mode, to accelerate the coherent energy transformations and convert it into detonation mode. So what he's using in the capillary is a hydrogen-containing substance like C3H8O5, stearin, paraffin, etc. The voltage on the magnetoplasma compressor capacity storage is around this, up to 300 joules, but he actually only used 80 joules. The distance was about this, and he's saying that the amount of material that is consumed from the capillary is about 1.2 milligrams per shot. He does some calculations here, and he comes out with effectively that per atom of material that's coming out of the capillary, they are producing equivalent shockwave energy, which is much better at determining the excess energy, he argues, and he's an expert in this. 2 million electron volts per atom, which is extremely close to the 2.1 million electron volts per atom that was observed in the 225-day nickel and hydrogen reactor with a tungsten heating rod that I presented at ICCF 22 in Azizi on behalf of Dr. Alexander Parkhomov. So Dr. Alexander Parkhomov had claimed that his reactor, in the fullness of its 225 days of running, had produced the equivalent of 200 mega electron volts per nickel atom, and this is producing it per carbon and possibly hydrogen atom. Actually, it's looking at the carbon atom, so per carbon atom. And so obviously carbon is a little bit cheaper to use as a source than nickel, and easier to work with. And so here is the initial plasma jet that's coming out of the erosive plasma capillary action. And he argues that in the center this is hydrogen, and then these are ionizations in the atmosphere and so forth. And then he ignites, and you've got this self-organization going on as it goes down here. Now, he argues, initially, he says that the plasma piston is typically moving at around 2,000 meters per second. 2,000 meters per second. But he actually says that they have achieved 10,000 meters a second, which just so happens to be a little over 22,000 miles per hour, which just so happens to be the speed that is recorded by A.C. Holt as claimed to be observed for UFOs in his 1979 propulsion propulsion proposal for NASA. And A.C. Holt went on to run the plasma propulsion, or the propulsion program at NASA, and worked with and around one Richard Estridge, who happened to develop plasmoid-based propulsion systems. Okay. Well, anyway, I'm just saying, 22,000 miles an hour is what he's effectively claiming is coming out of this. So there we go. All right. So here is the shock wave, and you can see, depending on the voltage, you've got different shock wave fronts, and they can determine, the power that comes out of this. But it gets very, very interesting when we look at the elemental transmutations. But before we go there, I just want to show the principal problem that has been solved, which I mentioned earlier, which has been the bane of Eric Lerner's life at LPP Fusion, and that is the anode gets damaged. So I'm going to pull up a paper now of another MPC generator, if I can find it. Okay. What one was it? Okay, so this is a typical MPC, miniature magnetoplasma compressor. Miniature, and this is from Mashek, Physical Department of St. Petersburg State University, Russian Federation, and so on. Koleshnenko and Brovkin at the Plasma Dynamics Division at the Institute of High Temperatures of Russian Academy of Sciences in Moscow, etc. And so this is the normal configuration of one of these MPCs. And you can see how the original inventor, why he would have referred to this as a why Morozov would have referred to this as a hedgehog and a snake. So the snake is in the middle and the hedgehog is on the outside. Okay, these are the cathodes and this is the anode. This is why I think in Anatoly's presentation he's got not got this quite right. Anyway, as we come down here, you can see the plasma, and this is the compression area here. And what is normally noted is that the anode is slightly shorter, as you can see here, than the cathodes. So the anode is slightly shorter than the cathodes, and so you can see, if I can zoom in maybe, you can see here, this is the kind of shadow of the anode in here, and they are pointing down here to just in front of the anode is where the compression area is. And you can see a long-lived plasmoid being ejected out here. And if you look at these from different angles, they actually look like a big torus. Okay? Like a big torus. So there you can see it's coming out. You can imagine this is a ball, and they say it produces like a ball, But the problem is, when it's doing this thing and it's trying to self-organize this plasma, it's got this large lump of metal in the way. And so when we go down here, here we can go. This is where they're using it to look at hypersonic interactions with different materials. So they're looking at the Mach numbers here. Here's another one where it's looking at the impact. So here is our plasma, self-organized plasma shooting out, and here is a pendulum with a large metal plate on it being displaced by the pulse coming out here. They can see how much that does. Okay, so I haven't got the erosion on this one. I will go and have a look at another one, see if I can find where I put it. Well, here's another one. Maybe it's in this one. We'll see. This is by the University of Belgrade Faculty of Physics in Serbia, and it's from December the 14th. Nora Turkia. It says, the Magnetoplasma compressor, a quasi-stationary plasma accelerator, is a source of supersonic compression plasma flow. High plasma parameters of compression flow, large flow velocity, and discharge during duration enable their efficient usage for the development of new plasma technologies, including material surface modification, creation of sub-microstructures and nanostructures. In this paper, spatial and temporal distribution of emissivity was studied using inverse Abel transform, blah, blah, blah. Okay, all right. So we're only interested in the pictures. Here we go. There is our hexagonal plasmoid type structure. Here is an octagonal array of electrodes around here with our hedgehog and our snake. And here is the typical kind of a regime. This is the ionization zone there, and this is the compression plasma flow. So you can see it right there. Compression plasma flow, image of flow photographed with camera using violet filter. So there we go. That's the compression going on there. And can we see anywhere here? This is one of those impacts. Nope, this isn't the one. I will find it. I've got a whole bunch of things here, and that one wasn't it. Let's try this one. This is actually creating ball lightning using these kind of technologies. This, I think, is in China. So this type of technology is used for a wide array of explorations of long-lived plasmoids. So here's a whole array of things going on the top of a moisture tank, and this is a bit like the Bitchkov work where they fired a plasmatron across a water tank, something like that. Anyway, you can see some nice vortices starting up here with the plasmoids. Really rather lovely. There's even one that looks almost like a perfect yin-yang somewhere here. Where is it? I don't know. One of these. Anyway, I think this might even be Bitchkov's work, and which they're kind of replicating. So here we go. We've got some long-lived plasmoids coming up from here. What does that look like? I do not know. Look at that one. Yeah. Not at all like a torus, yeah. Side on. Okay, I think this is Bitchkov here doing something similar. And I think Bitchkov's work was using a plasmatron or a similar device. Okay, I will find it here. I'm getting there. That's actually Anatoly's Klimov's paper. Oh lordy, where is it? Index, I've got that one. JT, I've got that one. I've got that one. Well, back to the capillary discharge. This one here actually shows that here's our little plastic capillary. Here is a capillary discharge. Here is its impact down here on a chunk of metal. So you can see it comes out really quite far. And that is an impact on a chunk of metal, which obviously has done it some damage. Some more impact. Anyway, I'm not finding what I want here, so I do want to show you the damage that the plasma focus devices tend to do to a electrode. Let me see if I've where have I got that paper? Not there. Maybe I didn't download it. Bear with me a second. Oh, damn it. Maybe I didn't download it. That's annoying. I had a beautiful demonstration of how terrible electrodes can be destroyed. And I don't know whether I downloaded it, which is highly tedious. Does anyone have any questions? Whilst I am fiddling around trying to find out what I lost here. Okay, well, I'm going to go back to his presentation just to talk about the transmutations. We'll see if we can find that. But trust me, the electrode gets really messed up. I will find it, but we need to make some progress here. So essentially what he found was in his spectra, he found these two state of ionization. That is to say, there are two electrons taken off this zinc ion rather than just one like this spectral lines. And he was rather shocked at this because he has no explanation. Reason being is that the energy of what's going on here is 3 or less electron volts. Now, why do I say that? Well, because if you actually do the maths and you see what temperatures are in, for instance, a lightning spark, that's lightning from the atmosphere, that's about 30,000 degrees Kelvin, and that turns out to be around about 2.6 eV. So he's saying in this system, there is no thermal energy higher than 3 eV, which works out in degrees centigrade about 34,500 degrees centigrade. So it's impossible to get what he observed, which is even third level of ionization. Now, he didn't say which one was giving third level of ionization. He only showed these ones. And these ones, I can only see 1 and 2, 2, 2. So nitrogen 2, copper 1, zinc 2, calcium 2, carbon 2. Okay, so The highest one here is nitrogen 2, which is 29.06 EV, but he did say that it goes up to 40 EV. And that is absolutely phenomenal levels of so-called thermal energy, but it's impossible. He says there's no conventional explanation for why you would end up with ionization levels and spectra from that. But I believe I have already explained this. I believe that what happens is what's happening in the sun. Some exotic vacuum objects, which are not exotic, they're ubiquitous, they are causing the actual fusion process, and they are in an energy soliton, in an exotic vacuum object, in like a magnetic structure. And they go up the field lines of solar prominences, and then they destabilize, and that's where you see this coronal rain, and some of them go into the corona, and the atoms that are born from fusion in there come out, and they are bare or with reduced numbers of electrons in their electron shells. So when they get born out of this structure, they then have to gain electrons from the environment, and they appear at millions of degrees. And I believe this is my explanation, has been for a long time. I made a very public video about it some time ago, that this is my explanation for what is going on in the sun, causing the coronal temperature being, millions of degrees, supposedly, because you see these spectrum lines that can only be achieved by millions of degrees in a black body kind of heating it up basis ordinarily. And the Earth's surface of the sun is in the 6,500 degrees centigrade, or whatever it is, Kelvin, whatever. There's a big discrepancy there. So what I am arguing here is that a magnetic structure, very specifically the fractal toroidal electrodynamic magnetohydrodynamic structure, is self-organized and forming in that self-organized plasma, which Anatoly has done a very good job of creating the environment for. That builds the magnetic strength, and it is magnetically confining and pushing those items together at the phase singularity, the topological monopole at the core. The exact same place that we found out after we've been discussing this for years was in the classified patent by Cooley and Bennett, in the center of the magnetohydrodynamic structure, specifically the fractal magnetohydrodynamic structure, the fractal toroidal moment, phase singularity. And fusion is occurring in there, and what comes out is partially electron depleted nuclei, or atoms rather. And I did a quick set of equations here using the Nanosoft reaction calculator, and I'll do this a little bit more detailed, and I might have got it wrong, but I'm just going to throw it out there for now, and it is this. Maybe I can show it here. Do I do it like that? Okay. Right. I don't know how I can get this bigger. Maybe I can go like this, and I can go like so. Okay. So I'm going to argue a case here, and the case is this. I think that on his chart, he's not showing any ionization of 40 EV, but he does say that it is observed. And I think it is from lithium 3+, because that is as much as you can possibly ionize lithium. Okay? Lithium 3+, okay, up here. That is 40.01 electron volts. And I suggest that all protons are stripped off electrons. So all protons are stripped of electrons as they go into this magnetohydrodynamic structure, or they may not be, actually. You need some protons and some atomic hydrogen, that is a proton and an electron. And then relic neutrinos in there as well. The weak interaction caused 3 protons to fuse with 3 atomic hydrogen. Okay? I've already said that H2 is not, that I repeat, not magnetic, but a proton and a atomic hydrogen, that's a proton with an electron, is paramagnetic. And so they can be pulled into this magnetic structure and into the topological monopole, and you get 3 antineutrinos combining with the 3 atomic hydrogen, and you get to the production of 6 lithium. But the 6 lithium is bare, and the 6 lithium is then spat out of this process, resulting in a 6 lithium 3+ nucleus, which would ordinarily require an ionization of 40.01 eV. 40.01 eV. That is bang on the maximum ionization energy that he claims to have seen in this experiment. Now, the next thing is C2+, which is 24, N2+, which is 29, aluminium 2+. Now, just for example, the aluminium could be made by the fusion of ions of 12 carbon and 14 N. That is to say, an ion that, because in these magnetohydrodynamic structures on the edges, it has been shown in that paper in 2021 that the charge separation there is 3.6 trillion volts per meter. That was enough to rip off the electrons. Forget necessitating all of the changes of the dielectric constant, the physical vacuum in there, which may make the electrons, or will make the electrons behave completely differently. Just something inside this intensely magnetic structure is causing the electrons to come off the atoms. But anyway, if we fuse a 12 carbon and 14 nitrogen and an atomic hydrogen, a proton electron, essentially we get aluminium and a 2+ ionization state. In the calcium 2+ state, which was observed, this was observed, this was observed, you get a fusion of 2 ions of 12 carbon and a 16 oxygen, because basically what I'm saying is you need an ion and an ion because they go in, and you need 16 oxygen is already paramagnetic, whether it's an ion or not, and so you end up with an oxidation state, or rather an ionization state of 2+, 2+. In the case of zinc, you just get the copper ion singly ionized, and then you hit it with a proton, and then you end up with, again, a 2+ ionization state. So I didn't really explain that well, and hopefully those people that have been following me for many years will understand where I'm going with this. But I'm saying that when you do the reactions in there with the elements that are in there, because we know we have nitrogen in the air, we have oxygen in the air, we have carbon in the fuel, and we have protons and electrons in the fuel, okay? We have all of the elements to make all of the elements observed in all of the ionization levels observed, but not by thermally heating it, by the actual nuclear reaction that's occurring magnetically in this process. Okay. So, I think these are explained by the same way I explained the coronal heating problem. The ionization states are impossible in the temperature that is occurring in the plasma state ordinarily in these systems. I believe it is a result of magnetic-based fusion and confinement of these structures. In the structure of these elements. The other elements he observes is sodium and silicon and aluminium. Okay, so the other thing is that emitted from this plasma is up to 2 keV X-rays, and so that can be caused by the emission of photons up to 2 keV from the plasmoid, And this is the condensation energy that you seem to get out of a exotic vacuum object as observed by Ken Shoulders. Okay, so his conclusion are that he has developed a unique MPC EP, and so just to get our terms correct here, the MPC is a magnetoplasma compressor. Magnetoplasma compressor, originally developed for studying fusion. Okay, and the erosive plasmatron is essentially a capillary discharge with a explosive plasma running through it. So he's combined that, the MPC and the EP together, and he can create a stimulated coherent energy transformation detonation in the EP's heterogeneous plasmoid. And it is triggered by the MPC's magnetic compressor mechanism. So, whichever way you look at this, one of the most serious researchers in the world with a history going back to the 1970s is saying the fusion process is caused by magnetic compression. There we go. The heterogeneous plasma consists of cheap carbon nanoclusters. This is no fancy-pantsy specific combinations and treatments to palladium with impurities and rolling and oxidizing and heating and reducing and rolling and oxidizing and producing little features in there and everything. This is just shoving a little bit of plasma shockwave through a capillary that strips off nanoparticles of carbon and hydrogen ions. The optical spectra have been obtained in the heterogeneous plasma. It was revealed that there are many optical lines of new transmuted chemical elements such as lithium. He says it's really abundant, the lithium. And if you're not getting there from fission from the other things, which you may be getting there from fission. He argues that it's from proton fusion, which requires the production effectively of neutrons, but it isn't producing neutrons. I believe it is a simultaneous reaction that is occurring through the weak force, and we know the weak force plays a role in these things because we have beta decays going on, and so that is occurring. Aluminium, he also says silicon and sodium, calcium and zinc. Zinc is obviously from proton interacting with the copper, and they're excited states with high excitation energy of 20 to 40 eV. 40 eV, because if you actually look at the higher excitation ion states of, say, calcium, it's over 40 eV. The one that fits is lithium 3+, and that fits the model where these are produced through the weak force in the magnetic compression of the fractal toroidal moment in the fractal magnetohydrodynamic structure. Intensive soft X-ray radiation with a quantum energy of less than 2 keV, exactly as was observed by Ken Shoulders, and a flux of low energy neutrons, although he specifies they might be fake neutrons, and I agree they might be fake neutrons, have been detected in the heterogeneous plasma. The estimated specific release of extra thermal energy in the HP is about 2 megaelectron volts per atom. So I want to give a big hand out to Anatoly Klimov. Well done, mate. Full respect. I hope you can come and talk about this specifically, and I can ask you some more detailed questions on the MFMP's website. But what you have come up here is you have solved the erosion problem suffered by anyone that's used these hedgehog and snake systems like Eric Lerner and other authors over the years by replacing the snake anode with a heterogeneous plasma caused by filled with carbon nanoclusters and hydrogens, which are the principal fuel, which makes it cheap and repeatable and can be done pulsing, and you've layered COPs on top of each other, just the heterogeneous plasma from the system produced by the Aramenco generator. You've got Aramenco generator, heterogeneous plasma, and the magnetic focusing going on there, plasma focus. It's just Just absolutely beautiful. And you're not bothering with excess heat, you're just looking at the shockwave dynamics. Absolutely beautiful. It removes a lot of the issues. And he actually argues that these devices are relatively simple to make, and I would agree. There's a lot more complicated things going on in LENA around the world, and this is relatively simple. So I've asked him to see if he can assist in making a replication. I think it would be a good one to do. And here we go. This is the overall system that we are looking at here. So are there any questions there? Question: what is the best way to generate energy from this detonator? What's the advantage over Klimoff's other simpler patent-based of N-gates hydrogen plasma energy system, energy cell? Well, the problem with those other systems is they are it's about the robustness and simplicity of making them. They are pretty good, I think. The energy cell breaks down after a number of hours because the cathode gets clogged up. Right, the electrodes get clogged up. This, I think, will be quite robust, and you could obviously have, you know, a method by which you easily replace the erosive discharge, or you find some way of, you know, this thing could just pop out and pop back in with a new pellet, and it runs for, you know, 10,000 pulses, and it pops out and pops back in again. So, you know, you would do the maths on it, but these electrodes are far more robust for surviving because they're big fat pieces of copper, and they're not where the plasma focus is. They're the thing that enable the plasma focus. So the hedgehog is not the problem with a normal plasma focus device. It is the actual snake, and he's removed the snake, and the snake is the fuel, and so it does a much better job. And so I think how you could use this is you use it in a kind of PAP device, don't you? It's a shock wave. You can use that shock wave and it can go up, and because it's a plasma, in the PAP device, the PAP cylinder, he would actually have a, in the cylinder head, he would have it as like half a torus. And so as the plasma would expand, it would hit that and it would go into a hydrodynamic vortex torus, and that would push the piston up with a shock wave. And because the charged particles are moving around like that, around the outside of the cylinder, he would have a pickup coil, and he would pick up electricity from magnetohydrodynamics. So you would actually get very large pressure mechanical energy, and then you would also get electrical energy out of it. And it could directly be used as a propulsion device. I mean, it literally, because it works in air, it could literally be like, pum, 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 pum. You know, you could, and it's basically using coherent energy transformations to produce a shock wave to propel something forward. Really rather good. And, you know, it's also, you could argue, something that would work even in space. I mean, because it's chucking an impulse out the back there that's traveling at up to 22,000 miles an hour, and it's got a mass and it's injecting it, but it's all electrical, isn't it? So if you could combine the system so you have it capturing magnetohydrodynamic generation, and it's got an over unity, then that could feed round and actually provide the electricity for the impulses, and you get the mechanical shock wave as a bonus. So you know, you could find yourself being able to do very effective propulsion with very, very low mass ejection. I'm gonna just bear with me. You think of your questions, and I'm gonna see if I can find this picture of the anode being eroded, because it's gonna be in one of these windows, I'm pretty sure, not that one. So think of your questions, and I will see if I can find what I lost earlier, because I thought, there we go, that's perfect demonstration of that, and then now I can't find it. Not there. Nope. Ah, dear. Wow, what did I do with that? Did I just close the window? I think I might have done. What an idiot. Unless I downloaded it to a different directory, which is also possible. Just talking to myself. Well, anyway, you will find out there. Maybe I can just search on erosion. Oh, I found it. Ah. Okay, I'll keep it in the window. Right, here we go. So this is by V.M. Astashinsky of the National Academy of Sciences of Belarus, and Ivan P. Dojcinovic, University of Belgrade, and Milorad Karaitsa, University of Belgrade. Wow, that guy's got a lot of citations, 3,346. Well done him. Okay, and diagnostics of magnetoplasma compressor of compact geometry. Okay. Quasi-stationary plasma accelerator of magnetoplasma compressor type with semi-transparent electrodes operating in an ion current transfer regime has been constructed and studied. Main discharge, blah, blah, blah. Okay, so fine. La, la, la. Here's the nice graphic of it. This has 8 electrodes. 1, 2, 3, 4, 5, 6, 7, 8. Yes, so this is the hedgehog. There's the snake. Again, the point of compression here is just behind. Okay, here we go. We've got a specially shaped insulator is positioned between the anode rod. It diminishes the level of impurities in plasma as per Astashinsky et al. In 1989, right? This is well studied. This is really well studied. And it's amazing that it's taken so long for Klimov, or for anyone, to do what Klimov has done, which is to replace the bit that fails. And how does it fail? Somewhere down here. Well, okay, so here's some plasmoids being ejected from the compression device. Okay. However, and there we've got the MPC principle going on here. So you can see the compression focus, plasma focusing going on. Okay. But down here you will see the typical damage you get, right? So it's saying erosion of MPC cathode side-on image. So actually in this case this is the cathode. Okay, so maybe it is the cathode and these are the anode, whatever. I need to check. But anyway, this electrode tends to get destroyed, and here is an example of it being destroyed. Okay. That is about that. So that's the one I wanted to show you, which I will now save. If I can, down here, I'll save it here. Okay, it's saved. Right, I won't lose that now. Okay. All right. I like the idea of pushing a piston, but I also creating direct to electric. PAP and the thunderclap are good examples, yes. I don't know, EBB. Sorry. Maybe you could reach out to Paul, who is back in Canada. He's asking about octal base vacuum tubes. Anode middle, cathode outside. Yeah, Alex, that's what I think. He, in the video, talks about the cathode being on the outside. He then refers to the erosion plasma jet as being also a cathode. So I think it's just, maybe he's got his wires crossed there. Okay, so I'm just going to run over it again. This is a bonus presentation because Mr. Klimoff gave this presentation on Wednesday. Unfortunately, it's very sad that the committee did not allow him to present at ICCF 25. I think this is a very significant contribution. He solved several problems, both of one of the most important plasma research devices ever made, and the fuel that is used in plasma fusion systems. He's combined his extensive knowledge of plasmatrons or erosion plasmas with his work on Tesla-like coils to drive them in the Aramenco generator. He's combining all of these things together in this really rather lovely little system that works in free air. So it's one of these things where you can actually observe it happening. And the elements it's producing, the most heavy one is zinc, which is good for the skin. And it's producing silicon, which is in the ground, and it's producing calcium, which is not such of a problem to you. Lithium, you know, it's producing lots of different things which are not super duper toxic, and a very visceral experience that you can get from doing this research. So cheap carbon nanoclusters and hydrogen come out in a combination from erosion discharge. The system itself ordinarily produces a COP of 2 to 4. He's saying that the actual Aramenco generator was of that same order, and he's getting all of this coming out, and this energy saturated heterogeneous hydrocarbon plasma is then being detonated to produce a shock wave, which is his determination of the energy released, which is one of the most valid ways of determining released energy by very, very well-known physics in very old papers which are recognized. And so cathode, anode, I believe, in the middle, a Aramenco producing a spark. That spark shockwave does erosion plasma, and its plasma focus occurs, and without restriction it does it just in the channel. And from his previous work, which I'll actually show you if I can find it, the plasmatron work, it's actually already producing sort of charge cluster-like structures. Let me show you here. We need to kill the adverts. So I discussed this before here. And in this case, he's producing the erosion plasma. He has a microwave producing a plasma behind here, and then he uses a spark. And I think that they might be holding back a little bit, because I think they might already have a more advanced version that uses that system. And you can see these helical beams coming in here, this twisted braid here, which splits into two twisted braids. And even in Mach 2 airflow, they are able to move off in a direction. Anyway, quite impressive. And I talked about them in various contexts here and how they match other observations. Okay, so he shared this back in 2020, but it was work he did a long time ago. Okay, so overall setup, measuring the shock wave from the device, give them a Lena reaction, and based on the shock wave, he calculates it's 2 million electron volts per atom is produced, which is in line with the nickel hydrogen system. Why use nickel if you can just use carbon, and you simply produce the nanoparticles as you need them. Up to 22,000 miles an hour. Ejection, very effective propulsion can be generated from this. So you're converting fusion energy into propulsive force. The ionization here, I could explain, which he couldn't, using exactly the same method, which is compliant with magnetically confined fractal toroidal geometries at the topological monopole, leading to heavily ionized nuclei as they are born out of these structures when the confinement collapses. So it appears like they've been ionized with high energy, but it's just because they've been formed in a system where they come out electron depleted. They produce these emissions of something that would otherwise have to be heated to very high temperatures. So he says there's no way in this system with energy below 3 eV that you can get up to 40 eV levels of ionization coming out. And the only one that could be 40 eV by my calculation is lithium, and that is completely compliant with lithium being born from fusion of protons, electrons, and antineutrinos. Yeah, so that explains the 40, and the 2 keV is the condensation energy of an EVO. And that is that. So, if there's no more questions, that's me done for tonight. The reason I did this today and not on Friday, on Sunday, is because on Friday I am going to completely totally and conclusively end the nanothermite hypothesis for what happened on the event. Completely end the Stephen E. Jones hypothesis for nanothermite at the event. That is to say, what I will share on Sunday will categorically prove and be verifiable that it is nothing out of the ordinary, and that it isn't something that was deliberately placed there, and it wasn't something that caused the effect that we observed at the event. Of course, those that don't know who Stephen E. Jones was, he worked at Brigham Young University. You will see that in 1987, not 1989, he published a paper which is very well read and documented, and it was regarding cold fusion, but using muons, in a very prestigious journal, very well cited. And in 1989, I think it was, he replicated some of the phenomena of Pons and Fleischmann. However, his most read paper by far on ResearchGate is the one looking at active thermitic materials in the event. It's been read over 70,000 times. I think that one paper is more reads on ResearchGate than all of his other papers put together, although the 1987 and 1989, or somewhere between 1989 and 1992 paper, also about lone nuclear reactions, as it was called in the interim, those have been cited more, but his overwhelming body of reads comes from papers relating to the event. And Stephen E. Jones was the person that basically put up his hands and ended the careers of Martin Fleischmann and Stanley Pons, or the credibilities. I will categorically show in very clear terms that that was not a thing. We will end that hypothesis. So you might see a trailer for that tomorrow, and do not miss it on Sunday. You will be able to do the same searches, and you will know that it is the case of what I am saying 100%. And I guess you would probably need to be of the skills of image recognition and searching capabilities of, say, a 7-year-old. A 7-year-old could verify with certainty that nanothermite, active thermitic material, was not deliberately placed in and part of the main reason for the failure of the structures on the event. Okay, with that, I will say thank you again to my friend and colleague in the fight for coherent energy transformations. That is one Anatoly Klimov at the Russian Academy of Sciences. And it's a shame that he didn't get his work presented like several others at ICCF 26 there. But I believe he has done a major contribution with this reinvented magnetoplasma compressor, replacing the key electrode that gets damaged with a highly energized heterogeneous plasma from erosive plasmatron action, allowing for the better formation of specifically fractal magnetohydrodynamic structures that have at their core a magnetic phase singularity, a topological monopole, where the action occurs as per the Warren and Cooley patent, which also uses carbon nanoparticles. So with that, I will say thank you very much for your time, and I'll see you in the next video. Buenas noches, dobranoc, good night.